Welcome. In this question, we're going to determine the mass of the ice that will melt inside the box after each hour. So now the question says the interior dimensions of a cooler box are 45 centimeters by 35 centimeters by 30 centimeters. Each wall is 3.75 thick, that is centimeters, 3.75 centimeters thick, and is made of a plastic whose thermal conductivity is 0.032 watts per meter per Kelvin. If the box is to maintain, if the box is to maintain an inside temperature at 0 degrees Celsius, when the outside temperature is 3 degrees Celsius, how much ice will melt inside the box each hour? So this is the information that we've been given. The data is, so we have for the dimensions for L, which is length 45 centimeters, breadth or width 35 centimeters, height 30 centimeters, and thermal conductivity is 0.032 watts per meter per. Okay, so here let's try first to we have to draw the box so that we can understand better how this question is all about. So the box looks like this, where we indicate also the interior or the internal dimensions, where L is equal to 45. So it is 45 by 35 by 30. These are in centimeters. So the L, which is the length, will be 45, and the B, which is the width, will be 35, and H will be 30, all in centimeters. So now we need to come up with something that is going to enable us to find the mass that will melt in 1 hour. So since we're talking about the ice melting, and also we are given the information here to say the temperature in the box is 0, and the outside environment, we have 30 degrees Celsius. So this is the information that we've been given. Now the data that we've been given there, the dimensions, I've talked about this already. And we also have the thickness of each wall. So the thickness of each wall, which is this and this. So the thickness, how big it is. It is 3.75 centimeters. So from there, we also have the thermal conductivity, which is 0.032 watts per meter per Kelvin. And then the temperature, 1, which is the initial temperature, is 0 degrees Celsius. And then the outside environment, which we're going to consider as temperature 2, is 30 degrees Celsius. And the time is 1 hour, which when we convert to the respective SI units, we're going to have 3,600 seconds. So this is the information, and this information is necessary to help us to find the mass of ice that will melt in 1 hour. So let us now proceed. We know that since there is an aspect of the thermal conductivity, we know that there is going to be some heat transfer by conduction. And that heat that is going to happen due to conduction, the rate is calculated as heat, the rate at which that one is transferred, or at the rate at which energy is transferred, is Q, which the heat over time, is equal to thermal conductivity times the area and also the change in temperature over the thickness. So this is the rate, at which this occurs. And if we make you the subject from here, we're going to have energy is equal to Ka T minus T0, or T2 minus T1 minus T1 times T over the thickness. And let us call this equation number 1. So this is the heat that is that results from the conduction of heat from the outside environment to the inside environment, because the outside environment is hotter than the inside box of this ice box. So now, from this, since we know that this is equation number 1, we also know that we want to find the mass of ice that will remain after, or that will melt after 1 hour. So the heat that is needed to melt the ice is heat is equal to the mass times the latent heat of fusion. So let us call this equation number 2. So now, since this equation, it is heat and this one is heat, so equation number 1 and equation number 2 are equal. So now let's proceed and find the mass of ice, where M, this is the M, the mass of ice. So we can say equation number 1 is equal to equation number 2. Let me just rub the top part here. So since these two equations are equal, we say 1 is equal to 2, M L of fusion is equal to Ka T2 minus T1 T over L. So making M the subject of the formula, we're going to divide by the latent heat of fusion, which is M is going to be Ka T2 minus T1 times T over L times latent heat of fusion. So from this, let us call this equation number 3. Equation number 3. But we have the T2, we have T1, and we have the thickness. And this one, it is a known value. It is a known value, which is 3.33 times 10 to the power 5. It is the value for latent heat of fusion. So that is known. So what we need to do is we need to come up with the area now. The area. So since it is a closed box and we want to find the total surface area, the total surface area of a closed box is found by area is equal to 2L times B plus L times H plus B times H. So 2 times, so we convert the dimensions into the SI units, which are meters, so 45, it will be 0.45 times B 0.35 plus the L, which is 45, 0.45 times H, which is 0.3 plus the B, which is 0.35 times H, 0.3. Okay, so this is going to give us, on a bunch on the calculator, we are going to have 0.9756 square meters. So this is the area. And the L, the latent heat of fusion, this is given by 3.33 times 10 to the power 5 joules per kg. So if we plug these values and the value for K in this equation, we're going to have the mass is going to give us 0.032 times 0.975 times the change in temperature, which will be just 30, times time, which is 3,600 seconds, over the thickness, which is 0.07 okay 75 0.0375 times the latent heat of fusion, which is 3.33 times 10 to the power 5. So when we punch this, when we punch all these values on a calculator, what we're going to have is 0.2200 kg, the units for mass. And finally, we can round it off to 0.22 kg. So this is the mass of ice. This is the mass of ice that will melt after 1 hour. Thank you so much for watching the video.